Hello.
Hello.
Hmm.
Excuse me, sir. Can you?
Yes.
Sir, you said of coordinates is equal.
Your voice is not audible. Your voice is not audible. You can. Sorry.
You said that number of generalized coordinates is equal to degree of freedom, right?
Yes. Yes. That should be there. The number of generalized set
Take
must
as
be
an
equal to degree of freedom.
something or
Sorry. Your voice is not audible.
is
Your voice is not audible. There is something wrong in your voice. Next doubt, please. You can just message me. You can just message me. Any another doubt? Number of degree of freedom is equal to generalized coordinate. Why you need proof? This is the definition. Because we have to talk about the number of the independent motion and how we will go for the independent motion unless until our variable will not equal to degree of freedom. Do you understand this thing? We need independent motion. Once we know the independent motion, then we can easily talk about the system. So this question is not any relevance. Okay, next doubt. You cannot doubt on definition. You can doubt on application and this type of thing. Next doubt.
full.
Sorry. Any doubt? Any doubt? This is just, I am just taking the doubt session such that we can go in a very smooth manner in next class. So I have login before the class for only doubt session.
सर
Yes.
इन फोर वेक्टर में सर आपने
No,
कराया था
no, no, no. Only from the Lagrangian. Only from the Lagrangian. Just ask the doubt from the Lagrangian, whatever we have discussed. Nothing else. Just you can ask whatever with the doubt. Otherwise, you are just wasting the time when the main lecture is there.
Excuse me, sir.
Yes.
Sir, how you get del I equals to 0 is extremum? I won't get that part.
What?
Del I equals to 0 is extremum.
Del I is equal to 0 extremum. What is meaning of maxima and maxima? First derivative will be 0, isn't it?
Sir, we
What
define
is condition?
maximum.
Huh?
First, we find the values of x, and by the second derivative, we find the maxima or minima condition. But
Yes, that is the same thing. That is the same thing. I am not using that you are going for the maxima or minima. I am just talking about either maxima or minima. Then only first derivative is enough.
sir, yes, sir, that.
Okay.
Okay, sir. Thank you, sir.
सर सर
Yes.
सर डिग्री ऑफ फ्रीडम से पूछना
पूछो पूछो, बिल्कुल बिल्कुल.
सर अगर स्फीयर में दो पार्टिकल मूव कर रहे हैं फ्रीली तो स्फीयर के सरफेस पे तब कितनी होंगी डिग्री ऑफ फ्रीडम?
अगर वो स्फेयर के सरफेस पे ही है रखा हुआ, then what will be degree of freedom? Only distance from origin will be fixed.
यस सर.
है ना? So you have how many degree of freedom? You have 4 degree of freedom, isn't it? Suppose it is move only on the surface of a sphere. Suppose this is your first particle, this is your second particle. Suppose this is radius A. So this will be for first particle, there is for second particle. What you have? X1 square, Y1 square plus Z1 square is equal to A. And for second particle, X2 square, Y2 square, Z2 square is equal to A. Isn't it?
Yes sir.
So we have 3 into 2 minus 2 is equal to 4 degree of freedom. And if you are going to the spherical polar coordinate also, if you are going to a spherical polar coordinate, radius is fixed, theta and phi is varying. So for first particle, theta and phi is varying. For second particle, theta and phi is varying. Okay?
Yes.
Just ask the doubt right now from your notes. Because today we will solve the problem. And during the solving of problem, if you have basic doubts, then it will be very tough for you. So I am just asking that, do you understand all the definitions or not?
Sir,
Hmm.
sir, I have a doubt from degree of freedom. Sir, from one book, JCU Upadhyay, it was question of particle moving on a space curve. So what does a space curve mean?
Space curve, I don't know what is a space curve means. I don't know. This is in plane actually. I think so. Maybe.
Okay, sir.
Okay. I think that is plane.
Okay, sir.
Okay. The curve in a space is plane, and curve on a plane is line. Okay. Some path.
Okay, okay, sir.
That is unnecessary. He is making the thing complicated. Okay. I suggest you just ask doubt from your notes, from your definition part, if you have any doubt.
Excuse me, sir.
Yes.
Sir, repeat the cyclic coordinate. What the definition of
Okay.
it?
Okay. Cyclic coordinate you want to repeat, no?
Yes, sir.
Look at what we have. Suppose I have Lagrangian, and this Lagrangian have n number of coordinate q1, q2, up to q1 and q1 dot, q2 dot, up to qn dot, and maybe function of time also. Okay. Now you have all coordinate. Suppose you are checking the some particular thing del L upon particular coordinate qk. If this will be 0, then qk is identified as cyclic coordinate. For example, in last class I have done, suppose I have Lagrangian half m x dot square y dot square plus mgy. Suppose this is my Lagrangian. In last class I have done this problem. So what is your generalized coordinate? You can write q1 is equal to x, q2 is equal to y. Even if x is not directly visible here, but x dot is here, na? If x dot is here, means this will be the generalized coordinate. Now, if you will check here, del L upon del Q1 means del L upon del X. That will equal to what? 0. There is not explicit function of X. If it is not explicit function of X, then it is 0. Then X is said to be cyclic coordinate. Okay? Do you understand this thing?
Yes, sir.
Okay, and same time you can also check for y. Del upon del y is equal to mg. This is not equal to 0. So this will be not cyclic coordinate. So y is not cyclic coordinate. Because degree of freedom is related to the kinetic energy part. It is nothing to do with the potential energy part. Okay. So in a kinetic energy, so we have x dot square, y dot square, and this is for the 2 degree of freedom. So x and y are the generalized coordinate. So if x and y are generalized coordinate, but this Lagrangian is not explicit function of x, so why it is identified as cyclic coordinate. Okay. Okay. Any more doubt?
So can you define generalized momentums?
Okay, you want to know generalized momentum. Suppose
Yes.
this is my generalized coordinate. Okay, then
Okay.
suppose I want to know generalized coordinate, generalized momentum about qi. So so this will be del L upon del qi dot. This is our pi. Okay, so this pi is generalized momentum corresponds to qi. Okay, now from here, from this particular thing, you can find how many generalized coordinate is there. 2 generalized coordinate, x and y. Then you can see del L upon del x dot is equal to px. So px is one momentum, generalized momentum, and del L upon del x dot you have mx dot, and similarly del L upon del y dot is equal to py is equal to my dot. So px is equal to mx dot is generalized momentum corresponds to x, and py is the generalized momentum corresponds to y. Do you understand this thing?
Okay, sir.
So these all things are mathematical. You have to do each and everything mathematical. ऐसा नहीं है कि आपको लगेगा कि you have to visualize something. No, you have to go with mathematical thing. Okay.
Sir.
Hmm.
Sir, in this Lagrangian that you wrote, if there is a extra term plus mgz, will z be
No.
a
Okay. Very
generalized-
good. Very good. This is not going to happen. Sorry, this is not going to happen. This is wrong Lagrangian. Straightforward, this is wrong Lagrangian.
Okay. Sir, how do
Why?
you understand?
Yes, yes. You have to see the kinetic energy term.
Okay.
If you are writing Lagrangian for the motion,
Yes, sir.
if there is not z dot, how you will introduce into generalized coordinate?
Okay.
Isn't it?
Okay, sir.
Yes or no? If this kind of situation will be there, suppose for x dot, I will write z dot, then it's correct. Then y and z are my generalized coordinate because z dot and y dot is there. So what you have to see? You have to see the kinetic energy part. What is kinetic energy? The kinetic energy is basically half m qi dot qj dot. So you have to see this term, and this will be tell you about the generalized coordinate. Okay.
Okay, sir.
It may be same. It dot term will tell you about the motion. Potential energy is nothing to do with the motion. This will just give the force and everything. Sorry, potential energy is nothing to do with the degree of freedom. Whatever the thing is, the kinetic energy will talk about the degree of freedom. Okay.
Okay, sir.
Okay. Okay. So I think this is more than enough, and let's go for today. We have actually problem solving class today, tomorrow, and day after tomorrow. So why we need to just discuss each and everything. At least you have to be very much comfortable what is generalized coordinate, generalized velocity, generalized momentum, and cyclic coordinate. Okay. But when we will do the problem, then you will much better, your understanding will be much better. So let's start with one of the basic problem, because then we will go for slowly, we will raise our level. And again, I will start with one again basic problem. Then we will, so what I will do, I will first analyze the one Lagrangian. And what is purpose of this Lagrangian? I want to learn how coordinate transformation is useful or coordinate transformation is not useful. Let's go for first, let's start with the basic, then we will do some coordinate transformation, and then we will try to understand each and everything. So let's have Lagrangian. So the Lagrangian of three degree of freedom is given as half m x dot square y dot square z dot square minus half k x square plus y square. So this is Lagrangian of 3 degree of freedom. Obviously, this is my kinetic energy and this is my potential energy. So what is generalized coordinate? So this is 3 degree of freedom. So how many degree of freedom we needed? We needed, how many generalized coordinate we needed? We needed 3 generalized coordinate. So yes, in this Lagrangian, we have 3 generalized coordinate. How do you know? I have x dot square, y dot square, z dot square. So I will just see the generalized velocity term. If generalized velocity is there, means generalized coordinate is there. Either it is shown explicit or it is not shown explicit. So never see the potential energy term. Always try to see the kinetic energy term. So we have 3 generalized coordinate. Let's say my first generalized coordinate is x, second generalized coordinate is y, and third generalized coordinate is z. Even if z is not there now, but z dot is there, and now, so this is my Lagrangian. What is my generalized velocity? Obviously q1 dot. So this is my generalized coordinate, this is my generalized velocity. q1 dot is equal to x dot, q2 dot is equal to y dot, q3 dot is equal to z dot. So this is my generalized velocity, and let's go for generalized momentum. So you can easily calculate each and everything. So just go for generalized momentum. If generalized velocity is there, then generalized coordinate is there. If generalized velocity is there, generalized momentum is there. So this is most important thing, generalized velocity. So what is generalized momentum? First term is del L upon del Q1 dot is equal to del L upon del X1 dot is equal to, let's say, Px. Sorry, this is not X1, Px. This is for X, so I am writing for Px. What will be this value? This value you can just differentiate partially, that mx dot. This is nothing but linear momentum. Second, del L upon del Q2 dot is equal to del L upon del Y dot. This will be, I will write Py, that is my dot. And similarly, we have del L upon del Q3 dot is equal to del L upon del Z dot is equal to Pz is equal to mz dot. So these three are straightforward. I am not talking about examination point of view. I am just talking about just a problem point of view. Now, let's try to get the cyclic coordinate. What are cyclic coordinate? Is that, so we have to check whether it is cyclic coordinate or not. So del L upon del Q1 is equivalent to del L upon del X. This will be minus Kx. So this is not 0. So x is not cyclic coordinate. Then del L, del Q2, del L upon del Y minus KY, this is also not equal to 0. So this is not also cyclic coordinate. Now del L upon del Q3 is equal to del L, sorry, this is del Z. This will be 0. You can see. Even if generalized, Z is generalized coordinate, but this will be identified as cyclic coordinate. So Z is cyclic coordinate. Now, if Z is cyclic coordinate, which quantity is going to conserve? Then obviously the momentum associated to Z. So Pz. So if this is cyclic coordinate, then Pz is equal to mz dot is constant. Now, if you have any doubt from here, you can just ask me. Okay, so these are all the definition part. Then we will go for, so you can see if this is the Lagrangian of some particular system and we are representing this Lagrangian into Cartesian coordinate system, what we have linear momentum along Z direction is conserved. So we have information that linear momentum along Z direction is conserved. Now, let me analyze why linear momentum in Z direction is conserved. Because you can see there is not any Z term in this Lagrangian.
सर बोर्ड क्लियर नहीं
क्या?
सर बोर्ड क्लियर नहीं दिख रहा.
Everybody have this problem?
No, sir. Yes, sir.
Clear.
No, sir. The
Yes,
board
sir.
is clear.
No, sir. Board is clear.
अब मैं क्या करूं? आधे लोग हाँ बोल रहे हैं, आधे लोग ना बोल रहे हैं.
सर क्लियर है
क्लियर है?
यस
अभी क्लियर है?
क्लियर है.
बच्ची जो बताओ, अभी जिसको दिक्कत था वो बताओ.
सर नेटवर्क है बट क्लियर नहीं आ रहा.
सर वो बार बार रेड हो रहा है जो
मेरा नेटवर्क.
यस सर.
यस सर.
नो सर, वाइट ही है.
What I will do?
सर नेटवर्क क्लियर है, आप क्लास लीजिए सर पूरा.
ओके. सो आप देख लो जरा अपना, एक बार नेटवर्क देख लो, चेक कर लो, या ऑफ करके ऑन कर लो डिवाइस, है ना?
क्लियर है सर, सब क्लियर है क्लास.
सो क्योंकि अब मैं तो यहाँ से कुछ नहीं कर सकता अभी तत्काल. हाउ मेनी पीपल हैव प्रॉब्लम?
नाउ क्लियर.
एक ही है नो क्लियर, क्या ना? और बाकी का?
सर और सर क्लियर है सर बोर्ड.
ओके.
क्लियर है. क्लियर है.
Okay, then I have to go for it. You can just check it. What is problem? Just you can check your device, okay, or internet connection. Because मुझे तो बिल्कुल clear नजर आ रहा है, okay. Now, so this is all about your Lagrangian, and we have just talked about that Z component is conserved. The linear momentum of Z component is conserved. Okay. Of Z direction is conserved. This is all about linear momentum in Z direction is conserved. Okay. Now, let's try to go for equation of motion. So when we will go for equation of motion, we have to write for 3 equation of motion because there are 3 generalized coordinates. So how we will go for equation of motion? So first we will go for first equation of motion, that is d upon dt del L upon del x dot minus del L upon del x is equal to 0. So when you will put it here, then d upon dt mx dot, and this del L upon del x is equal to minus kx. So minus kx is equal to 0, and this thing is mx double dot plus kx is equal to 0. And similarly, we can go for y direction also. So when we will go for y direction, then what you will get? You will get something like same type of equation. So what will be d upon dt del L upon del y dot minus del L upon del y is equal to 0. And again you have d upon dt m y dot minus ky is equal to 0. What is meaning of that? Meaning of that, you have basically m y double dot plus ky is equal to 0. And now look at here. This is exactly, we have equivalent to Newton's law of motion. This is exactly Newton's law of motion, isn't it? F is equal to ma kind of situation is there. What is x double dot? X double dot, you can write something m d square x upon dt square plus kx is equal to just like as a harmonic oscillator in x direction. But what about y? What about z? Z, if you go for the equation of motion, then how you will write for the z part? So if you will go for equation of motion, then the z part is d upon dt del L upon del z dot minus del L upon del z is equal to 0. And now this is 0 because it is cyclic coordinate. The second term is going to 0. Then what will happen? D upon dt m z dot is equal to 0, which means this mz dot is constant, and we have this is pz and this pz is constant. So from the equation of motion, we have again this type of situation. So if I find this is my cyclic coordinate, then there is no need to solve this thing. If you will solve it, then obviously you will get the same condition. So it's a very interesting thing that cyclic coordinate will just tell you about conservation of momentum. But if I will ask you that whether angular momentum, can you tell me anything about angular momentum in this problem? No, because everything is linear. You cannot tell anything about angular momentum in this particular problem. So let's try to just change the coordinate system or transform the coordinate system, and then we will try to analyze each and everything. Right now, if you have any doubt, just you can ask me. If you have any doubt, you can just ask me.
No doubt, sir.
Okay. Please म्यूट कीजिए जो भी है ना? बेबी की आवाज आ रही है, म्यूट करके रखिए. Now, let's try to go for transformation of cylindrical coordinate. Why cylindrical coordinate? I will just discuss. First, let's go for cylindrical coordinate. What is this cylindrical coordinate? I have x is equal to r cos theta, y is equal to r sin theta, and z is equal to z. And when you will just transform these all thing in the cylindrical coordinate, we have find how x dot and y dot behave. And when you will go for cylindrical coordinate, then this will be half m r dot square r square theta dot square plus j dot square minus half k r square. So now look at in this particular problem. Now if this is my Lagrangian and this is Lagrangian of same system, I have just transformed this coordinate system. So what are my generalized coordinate now? So my generalized coordinate is, now my generalized coordinate is q1 is equal to r. So I am just going to write generalized coordinate. q1 is equal to r, q2 is equal to theta, and q3 is equal to z. Why? We will see this particular dot square dot term. R theta dot is not generalized coordinate. What is generalized coordinate? R theta and z. Now let's try to go for generalized velocity. So what is generalized velocity? So this is q1 dot, that will be r dot, that will be q2 dot, this will be theta dot, and here is q3 dot, that will be z dot. And now we can just go for generalized momentum. So generalized momentum, so first will be del L upon del R dot is equal to, I can say PR, this will be MR dot. And second term, I have del L upon del theta dot is equal to P theta, and when we will differentiate with the theta dot, this is all about theta dot, when you will differentiate it, then mr square theta dot is there, 2 and 2 will cancel. So this will be mr square theta dot. And now when we will go for, again z is also my generalized coordinate, then we have del L upon del z dot is equal to pz, and that will be mz dot. This is very trivial. Once you know the generalized coordinate, generalized velocity, you can find the generalized momentum. But I am interested into cyclic coordinate. Is that r is cyclic coordinate? So let's check del L upon del r, and if I can see, this will be m r theta dot square minus kr. This is not equal to 0. So this is not cyclic coordinate. And second, let's talk about theta. Del L upon del theta, is that any function is theta? No, Lagrangian is not explicit function of theta. So what we have, del L upon del theta is 0, means theta is cyclic. So if theta is cyclic, which quantity is conserved? Then P theta is going to conserve. If theta is cyclic, then P theta is constant. And what is P theta? Mr square theta dot is some constant. Let's say this is constant number 1. And when you will go for del L upon del Z, then this will also 0. So what will be? Z is also cyclic coordinate. And from here, you can see which quantity is conserved. Pz is equal to mz dot, and this is my second constant value. So when we are changing my coordinate system, and this coordinate system is in cylindrical coordinate system, then we have 2 cyclic coordinates. So 2 things is conserved. The first thing is all about z direction of linear momentum. And second thing is P theta. What is this? This is linear momentum or angular momentum? This is nothing but angular momentum. P theta is angular momentum. So what we can have, I am just going to remove this part. So from here, we can just say that linear momentum in z direction is conserved, as well as angular momentum in z direction. What is direction of p theta? P theta is something is rotating in xy plane, then direction of angular momentum is in z direction. So p theta here for in a cylindrical coordinate, this p theta in which direction? This is in z direction. So what you will see, the angular momentum in z direction is p theta, and which is also conserved. So you can see that which coordinate is the better coordinate? Cartesian coordinate is better coordinate or cylindrical coordinate is better coordinate? Which is suitable coordinate for this particular symmetry? This particular whatever the system is there. Obviously, we will go for cylindrical coordinate because in the cylindrical coordinate, we can reveal more and more information. तो आपको अब ऐसा लग रहा होगा कि चलो let's go for a spherical coordinate, we have more beautiful information. So this is for your homework. Just try to transform this Lagrangian into a spherical coordinate. So just write down homework, just transform this Lagrangian into a spherical coordinate and then analyze the cyclic coordinate. Let's see what you are watching. Then I will discuss it tomorrow. First you have to do this thing. So this is my Lagrangian. You know this is Lagrangian. X dot square, y dot square, plus z dot square, minus half k x square plus y square. So what is your homework? Homework is transform this in a spherical coordinate. And then discuss cyclic coordinate. You will find that no, neither Cartesian coordinate nor a spherical coordinate is good coordinate for this particular system. Rather, the best coordinate is all about the cylindrical coordinate system. And now you have to write equation of motion only in r direction. Why in r direction? Because theta and z both are cyclic coordinate. So once you have this is cyclic coordinate, there is no need to write the equation of motion because ultimately you will get same thing. So ultimately you will get same thing. So let's go for write the equation of motion. So equation of motion we can write only in the r direction. The theta part is not important. So when you will go for equation of motion, then so what is my Lagrangian? So the Lagrangian is half m r dot square theta dot square plus z dot square minus kr square. So we have to just go for equation of motion d upon dt del l upon del r dot minus del l upon del r is equal to 0. So we have d upon dt mr dot minus del l upon del r. This will be m r theta dot square plus kr must be 0. This will be minus kr minus minus plus. This will be minus. So we have mr double dot minus mr theta dot square plus kr is equal to 0. And this is my equation of motion in a r direction. There is not any need to, the force is only in r direction. There is not any force in z direction and there is not any torque because theta is angular variable. So the force will be replaced by the torque because momentum is replaced by angular momentum. So what we have, there is not any external torque and there is not any external force in z direction. Whatever with the force in a radial direction, and this is your radial direction force. Now, if you want to know, you can also calculate about the equilibrium point. So we will just discuss this thing in later part. Right now, this is more than enough. What is meaning of equilibrium? Meaning of equilibrium at r is equal to some r naught, r dot is equal to 0, r double dot is equal to 0. So this is the condition of equilibrium. Okay. So if you have any doubt, you can just ask me. Otherwise, we will go for next problem.
So in this problem, how we get to know about the direction of angular momentum p theta, which is in z direction?
Because don't worry. This is cylindrical coordinate. In cylindrical coordinate, the part is rotating in xy plane, isn't it?
Yes, sir.
If particle is rotating in xy plane, then what will be direction of r cross v is in z direction.
So that is by
R
that,
is radial, v is tangential, then this is z direction. Okay.
by that conventional method only, no, we have find the direction.
Yes. In cylindrical coordinate, the theta dot is in z direction. This theta dot, what is direction of theta dot? That is in z direction. You have learned into your +2 level, isn't it?
Right hand thumb rule.
Yes.
Sir, please repeat this equilibrium condition.
इक्विलिब्रियम कंडीशन मींस कोई फोर्स नहीं हो, है ना? इक्विलिब्रियम कंडीशन का क्या मतलब होता है, तुम बताओ? फोर्स ही तो होता है, जहां पर कोई भी फोर्स ना लगे उसे इक्विलिब्रियम कंडीशन. फोर्स मींस दिस इज एक्सेलरेशन.
Yes, sir.
सो जब अगर फोर्स नहीं लगेगा तो एक्सेलरेशन भी 0 हो जाएगा. यस या नो?
Yes.
तो मींस r डबल डॉट मस्ट बी 0, है ना? r डॉट भी 0 होगा और r डबल डॉट भी 0 होगा. मींस देयर इज नॉट एनी मोशन इन r डायरेक्शन. ओके,
Okay.
अभी करेंगे, बहुत सारे प्रॉब्लम करेंगे, एक एक करके क्लियर हो जाएगा. सो लेट्स गो फॉर नेक्स्ट प्रॉब्लम. ओके, so this is first problem and this is basic. I think you all understand the only solving of the problem in any arbitrary coordinate is not important. What is important? You have to go for some suitable coordinate system. But don't worry, in examination they will ask you that write down Lagrangian in cylindrical coordinate, then everything is cakewalk for you. But yes, but for the subject point of view, you must do the thing from suitability. So let's go for one problem and then we will discuss it. Okay, so just we have a particle is constrained to move on a surface of ball. Ball देखो, this is something, this ball with equation z is equal to half b x square plus y square. So this is your equation is also given. So if you will plot it, this is paraboloid, the parabola which is rotating about z axis. So this kind of situation is there. This is x axis, this is y axis, this is z axis, and it is also given that gravity is in z direction. This is the direction of gravity along z direction. A particle is constrained to move under gravity, लिख दो, है ना? Under gravity on a surface of ball with equation. So their particle can be anywhere. Suppose this is my particle of mass m. So particle of mass m, you can write mass m. Particle of mass m is constrained to move on a surface of ball. So what we have to do? We have to write the Lagrangian. Write Lagrangian in cylindrical coordinate. So write Lagrangian in cylindrical coordinate. So we have to write this Lagrangian into cylindrical coordinate. जैसा एग्जाम में आपके पास प्रॉब्लम आता है, मैंने एग्जैक्टली वही दिया है. So let's try to write the Lagrangian. So obviously, first I will, so this is my 0, 0 coordinate. This is my 0, 0 coordinate. So what I will write, I will first write this thing as Cartesian coordinate system, because it is well defined. Because once you write Cartesian coordinate, then you can easily transform each and everything into another coordinate system. So this is Lagrangian, this is kinetic energy, minus this is potential energy. So I have this distance is z, this point is x, y, z. So what will be potential energy? The potential energy is minus mgz. This is your potential energy, this is your kinetic energy. If you want to transform this Lagrangian into cylindrical coordinate, then obviously I have to put x is equal to r cos theta, y is equal to r sin theta, and z is equal to z. Then we can transform this Lagrangian, and this Lagrangian is half m r dot square r square theta dot square plus z dot square minus mgr cos theta. Sorry, mgz. Sorry, not mgr cos theta. This is mgz. This is mgz. Now, the question is that this Lagrangian is correct?
No, sir.
Is that this Lagrangian is correct?
No, sir.
No, this Lagrangian is not correct. Why? Because you can see what will be degree of freedom. The degree of freedom here is given 3 into n minus k. So this is your degree of freedom. So 3 into 1 minus 1. This is equation of constraint. The z is equal to half bx square plus y square. This is nothing but the holonomic constraint. And in this problem, they have given you holonomic constraint. हमें यहाँ निकालने की जरूरत नहीं पड़ी. We have this constraint. So how will we constraint 1? So what we need, we have 2 degree of freedom. But here, how many generalized coordinate I have used? 3 generalized coordinate. I have used r, theta, and z. But degree of freedom is 2. So why this Lagrangian is not correct? What we have to do? We have to use this equation of constraint. We have to use this equation of constraint such that the number of independent variable must be equal to degree of freedom. So how we will go for this? And please, this equation of constraint is given in Cartesian coordinate. What we have to do? We have to just convert it into cylindrical coordinate. So let's try to go for conversion of cylindrical coordinate. So what we will do? So first we will go for z is equal to half b x square plus a square is equal to r square. And now we can put z here and we can put z dot here. So that will be half b r dot into 2 also. So then this is gone. So b r dot. So we can put z dot as b r dot. Then my Lagrangian will become L is equal to half m r dot square plus r square theta dot square, and z square is written by b square r dot square minus mgb r square by 2. Now I can collect r dot term separately and I can collect r term separately. So what will be Lagrangian? Half m, I will just take r dot square common. We have 1 plus b square r square plus, and then we have r square theta dot square minus mgb r square by 2. Now you can see what is degree of freedom. So degree of freedom is 2. And what is generalized coordinate here? We have generalized coordinate q1 is equal to r and q2 is equal to theta. So we have two generalized coordinate. One is r. So we have seen this is r dot square kind of thing. This is theta dot square kind of thing. So we have two independent variable. One is r, another is theta. So this is wonderful thing. Now I can say this is correct Lagrangian into cylindrical coordinate with this constraint. With this particular constraint into cylindrical coordinate system. So what you have to do? You have to focus on what is degree of freedom and what is equation of constraint. Are you using all equation of constraint or not? If you are not going to use all equation of constraint, then surely the number of generalized variable or number of generalized coordinate will not match with the number of degree of freedom. Then obviously you can see then your Lagrangian will not correct. Now, if you have any doubt, you can just ask me. Okay, so let's go for solving of this particular Lagrangian. So, and the solution is very interesting.
सर
So, yes.
सर इक्वेशन के हिसाब से सर ये फिगर नहीं समझ आया कि ये पैराबोलॉइड कैसे है, कैसे पता चलेगा? ये इसका इक्वेशन
ये
होता
पैराबोला है, ये पैराबोला है, z
Yes,
is equal
sir.
to x square.
यस सर
ठीक है?
यस
उसी
सर
तरह से y का लोगो तो एक परपेंडिकुलर एक्सिस में होगा पैराबोला, ऐसा कुछ नहीं?
यस 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 सर
तो अब इसको रोटेट करोगे तो यही तो होगा ना, 3 डायमेंशन ही तो बनेगा.
ओके सर
ठीक है, ये ऐसा नहीं, समझ में नहीं आया. एक पैराबोला लिखा, उसको रोटेट कर दिया जेड एक्सिस के अबाउट, तो
ओके
उसे
सर
क्या कहते हैं? पैराबोलाइड कहते हैं. ठीक है, और उसका इक्वेशन यही होता है. यानी वो एक्स में भी, इस प्लेन में भी है, दूसरे प्लेन में भी है ना?
ओके सर
एक्सजेड प्लेन में भी है और वाईजेड प्लेन में भी है. एक्सजेड प्लेन में भी पैराबोला है, वाईजेड प्लेन में भी पैराबोला है. ठीक है,
यस सर
और दोनों को मिलाओगे तो 3 डायमेंशनल पिक्चर बनेगा तुम्हारा, है ना?
यस सर
Okay. So, what is your Lagrangian? So, Lagrangian is half m r dot square, and I will write it separately. 1 plus b square r square plus half m r square theta dot square minus mgb by 2 r square. Now, is that any cyclic coordinate? Let's check. Is that r is cyclic coordinate? Then del L upon del R. So del L upon del R, we have m r dot square, and you will differentiate it. Then you have 2b square, and 2 will cancel. So b square r. This term I am differentiating with partial with respect to r. So this term will be something m r dot square b square r. Okay, now this term is plus m r theta dot square, and this term will be minus mg br. So obviously this is not equal to 0. This is so lengthy. This is not equal to 0. So r is not cyclic coordinate. Now, when we will go for del F upon del theta, yes, this is 0. This is 0. There is not any term of theta. This is theta dot. So del L upon del theta is 0. So theta is cyclic coordinate. Theta is cyclic coordinate. So if theta is cyclic coordinate, then which quantity is conserved? Then you have to go for del L upon del theta dot is equal to p theta. And what is this p theta? P theta is nothing but angular momentum. And which direction angular momentum? Again, it is z direction angular momentum, because we are writing in a cylindrical coordinate. P theta is m r square theta dot, which is constant. isn't it? This is angular momentum, I into omega. Look at, this is your z axis, this is your r, this will be some particle, this is rotated about theta dot direction. So this will be mr square is moment of inertia into theta dot this. So this is what? Angular momentum. And this is in direction of z. This is in xy plane, isn't it? So this is the cylindrical symmetry. So p theta is conserved. So here z component of angular momentum is conserved. Z component of angular momentum is conserved. Okay, so let's go for, so now we have to write only equation of motion in which direction? Only in r direction. So let's try to write equation of motion in r direction. So let's go for, and this is very interesting. So what will be del L upon del R dot? Obviously this is PR, and this value is equal to M R dot 1 plus B square R square. So this is PR. Now what will be equation of motion? The equation of motion is, I'm saying here, d upon dt del L upon del R dot minus del L upon del R must be equal to 0. So we have to write equation of motion in r direction. So how you will write it? You have to just go for d upon dt. This will be mr dot 1 plus b square r square. So this is del L upon del. So this will be something like that. Del L upon del R dot. I have put it here, and minus, I have to put this all term. This will be minus m r dot square b square r minus mr theta dot square plus mgb r must be equal to 0. Now just differentiate it. So most of the people are doing this type of blunder, that they will just write mr double dot 1 plus b square r square. Sorry. Okay, first you have to differentiate it, then you have to also differentiate it. Because this is total derivative with the time, and r is dynamical variable. R dot is not equal to 0. So r is dynamical variable. So you have, this is first function, and then you have to go for second function. When you will go for second function, then you have m r dot. When you will differentiate it, then you have 2 b square r dot. Do you understand this thing? This blunder have done a lot of people. They will just ignore this thing because you have total derivative with the time. And then we have m r dot square r minus mr theta dot square plus mg br must be equal to 0. And now you can have b is also, so b square is also, so b square is also. So you can see this is plus 2, this is minus 2, everything is there, r dot square is there, r is there. So this will be, one will reduce. So this mr double dot 1 plus b square r square, and this will be 2, 1 will cancel out. We have m r dot square b square r minus mr theta dot square plus mg br must be equal to 0. So this is my equation of motion. Look at, so lengthy, so lengthy. In mechanics or in quantum mechanics, you cannot avoid calculation. You cannot avoid calculation. The calculation is very must. Other topic I don't know, but in these two things, look at, this is only one problem. But don't worry, in the examination, they will ask some part of this. So it will take 2 minutes, 3 minutes. So you have this thing. Okay. So I hope you enjoy this question. Okay. So if you have any doubt, you can just ask me. This is just calculation, nothing else. It is very important that you have to do step by step.
Sir,
Hmm?
sir, sir.
Bolo,
In this,
bolo,
how
bolo,
the sir, in this, how z component of angular momentum is conserved?
P theta is conserved. P theta is constant. Say yes or no.
Yes, sir. P theta is constant.
P theta is constant. So what is P theta? P theta is momentum corresponds to theta. Theta is angular variable or linear variable? It is angular variable. That means angular momentum is conserved. Now, in a cylindrical coordinate, what is theta? Theta is theta dot. What is direction of theta dot? In the z cap direction, isn't it? If something is rotating in xy plane, then what will be direction of omega? In perpendicular to plane. So what is direction of p theta? That is in perpendicular to plane. Isn't it? Yeah, this is just a class 12 thing. You are moving in a circle. This is your velocity. This is your r. What will be direction of angular velocity? V cross r or r cross v, that is perpendicular to this plane. Isn't it?
Yes, sir.
So why that is the same thing, na? P theta. What is theta dot?
Yes, sir. Yes, sir.
Theta dot is perpendicular to plane, na? So if theta dot is perpendicular to xy plane, then angular momentum will also in xy plane. Sorry, angular momentum is also perpendicular to xy plane. So this is moving something like this, na? This is, suppose, where I will write. Suppose this is your paraboloid.
Yes.
Okay, this is your paraboloid. So which kind of motion is there? This kind of motion will be there, isn't it? So it is rotating. In rotating in which plane? XY plane. So angular momentum in which direction? Z direction. This is your X, sorry, this Y. This is your, so this type of motion is there. Okay?
Yes, sir.
So this is the first question we have encountered. So tomorrow we will do more problem. Don't worry. So we have next 3 days, we have only problems. So just go for the assignment. I hope you have got the assignments.
Yes, sir.
So just go for homework for the assignment. Okay. Okay. So assignment 1 you have, I am just giving you homework. Just try to do this thing because same thing is also there. So you will just go for question number 1, question number 2. Okay.
So,
Yes.
sir, I haven't got assignment.
You so just talk to staff. He will give you. Okay. So he also message in the group also.
Okay, sir.
Just check it. Okay. So question number 1 and question number 2 is your homework. Okay. So that will depends on same problem, same thing, saying exactly same thing, but you have to do little bit more exercise about equilibrium condition and about Z and everything. So just do it with yourself. Question number 1 and question number 2. Okay.
Excuse me, sir.
Yes.
Sir, if they have not mentioned in which coordinates we have to take the Lagrangian, then how can we get the idea of taking the
Then
Lagrangian?
you will just go for, then you have to do a lot of exercise. You can just transform the Lagrangian into different coordinate system. Then you have feeling of this kind of situation. Okay. So just try to write this thing into a spherical polar coordinate system also.
Okay.
Okay. So take care. Tomorrow we will have, I think the basic is clear. So now I will go for little bit tougher problem in next class. Okay. Thank you. Don't worry, Puneet. This is not only bus 3 questions. This is a lot of questions. Once your concept will be okay, then you will understand. Okay. So don't
Yes,
count in a
sir.
number physics. Okay.
Sir, actually, I was messaging someone else, so
Don't worry. Don't worry. Don't do type of thing. Okay. This is very, or this is not an ordinary class. You look this look ordinary. Huh? Okay. Take care. Don't count the number. Ultimately, you have enough thing. Okay.